So when NIDAC Embraco R&D team and the sales team, when we have the project with the vending machine customer, we make some research about this market, and we found there are three major contexts. First one is expanding quantity of vending machine applications in the market. The second one is a high life cycle cost requiring a solution to lower it. The third one is significant global warming and environmental impact caused by cold chain. So based on this kind of contract, we make the three targets for the project to help our customers. The first one is convert the compressor from fixed speed compressor to the variable speed R290 system. The second one is we want to help our customer to make the system optimization for lower energy consumption. The third one is reduce operation cost for the applications to enable more application into field. Then we started the project with customer, and here this page shows the original information for their system. In the beginning, they use Embraco fixed speed solution. The model name is FFI 12 HPK. It's a R134A HFC compressor. And the size is 510 liter. The vending machine for beverage and snacks. The target market is for China and Southeast Asia. Inside this traditional vending machine system, it includes two fan motor, two heat exchanger, one LED lighting, one door heater, one controller, one display screen. And here is the system flow. It's a very traditional system. And based on the analysis, in order to reduce the energy consumption and comply with the regional requirements, Embraco provides two solutions. From the compressor side, we suggest customer to use our variable speed R290 compressor to replace the old fixed speed compressor. The second one is we suggest the customer to redesign their system to adopt the more efficient part, especially the motors. Then when we do the test, firstly, we only focus on to change the compressor itself. Before the model is FFI 12 HPK, then we change to the VS870 is a variable R290 compressor. And you can see for the energy consumption test under 32 degrees C temperature, finally, we can clearly see it can save energy consumption by 27%. It is a big saving. And when we check the result about the pull down test at ambient 32 degrees C, the result shows as follows. For the old compressor, it can achieve 6 degrees C by 130 minutes. But when we change to the variable speed compressor, it can achieve 6 degrees C by 110 minutes. So it means the variable speed compressor can achieve faster by 15% compared with the old one. After the change of the compressor, Embraco R&D team also helped the customer to analyze the distribution of electrical devices inside their system. For example, here is the energy consumption map. From here, we found the door heater, evaporator, condenser fan accounting major power consumption. So we give customer two opportunities, two suggestions. One is replace the AC fans to the DC fans. The second one is reduce the runtime of the door heater to optimize cabinet power consumption. Then customer take all the solutions and make the final test. In the end, you can see the customer can save 47% about the energy. And inside this 47%, You can see the first one is related to the compressor. If they change the compressor from HFC to the variable speed R290 compressor, it can save 27%. And when customer optimize the door heating and replace the fan motor from AC to DC, it can save another 26%. Then there are small optimized regarding the beverage outlet, it can save 1%. So from this math, we can clearly see to change compressor from the fixed speed compressor to variable R290 compressor can take the major part for the energy saving. Then when we talk about the financial feedback, we make the calculation with the customer. If they change the compressor to variable speed solution, they can save $74 per unit per year. And this saving can easily cover the price and the cost of the compressor. So the customer can easily get the payback less than 1 year. And also when we talk about the global warming, the customer can save 24% based on this kind of compressor optimization action. So from the technically, when we talk about the variable speed technology, it can adjust the demand required by the refrigerator. So here you can see if the system requires low demand, the variable speed compressor can run with a very low RPM. When the system increases the demand, the variable speed compressor can increase the RPM speed. And for example, during the pull down and half reload period, the variable speed compressor can run the maximal speed, for example, 4,500 RPM to make the faster pull down. So all of this technology can achieve these benefits, for example, energy efficiency, low noise and vibration, wide voltage range, food freshness, then temperature stability. And another thing is related to the control. Before, inside the compressor industry, especially when we talk about light commercial business, there are a lot of manufacturers that are providing normal drop-in controller, I mean the inverter. But this very traditional drop-in inverter has some weakness point because the program inside the inverter is standardized. It cannot change due to the customer demand. Then Embraco, we develop a new solution and we call it a smart drop-in. From the picture, you can see that the customer, they can use the computer, the software to control the inverter, and they can customization of the control routine according to the cabinet. And the customer can make the specific parameters according to your needs. And optimization performance and energy saving. And this smart drop-in just need a stand-on-off thermostat. And this smart drop-in solution is very welcomed by our customers, and we already sell a lot in Asia Pacific and China market. So that's all for my presentation. And if any of you want to know the details about Embraco variable speed solution, it's very welcome to contact me. You can send an email to me. Here is my email address. Thank you very much. Thank you.
Thank you very much for your presentation. Let's see if we have any incoming questions from the audience. You have presented the numbers when it comes to the growth of your business in Asia Pacific, as well as the share of hydrocarbons. Is this going according to your plan, or do you see some positive surprise on the side of uptake of hydrocarbons in Asia Pacific?
Yeah, to be honest, let me say, from my personal, I feel surprised. Why? Because normally, inside the Asia Pacific, especially when we talk about Southeast Asia, everybody know that the local manufacturer, especially the OEM manufacturers, normally they move very slowly because they focus on the benefits from the business. Yeah, and especially when we talk about the refrigerant trend, US and Europe are leading the process. But inside the recent years, I can see there are a lot of customers from the Southeast Asia. They are willing to make the first change and make the first action inside the market to enlarge their business scenario. So based on this kind of willing, Embraco, we develop a lot of new opportunities with our customers. So to be honest, I'm surprised for the fast growing about hydrocarbon trend inside Southeast Asia. So anyway, I firmly believe we can sell a lot inside Southeast Asia and also China regarding the hydrocarbon compressors.
Thank you very much. That's great to hear. And Japan has been bit behind, let's say, when it comes to R290 in commercial refrigeration. Not always, not everywhere, but especially in the showcase for retail, supermarkets, convenience stores. It took a number of years, but this year in February, we have seen a lot of suppliers being visible with R290. A lot of the traditional players that never had R290 on display are now joining. So it points out to a change in the market in Japan and more wider acceptance of R290. Do you see this momentum as well?
Yeah, I also heard this kind of news, and I'm very happy Japan market make this kind of change because, as you know, Japan is a very important country inside Asia. And especially when we talk about Southeast Asia, there's a lot of customers, I mean, the OEM manufacturers, they have very close relationship with Japan. And now I believe if Japan move to R290, it can help all the Asia countries to move forward for the low GWP gas. Yeah, so I believe it's a really good trend.
That's again very, very reassuring for us in Japan to see this happening finally, because for many years Japan was very hesitant to go in this direction. Just, in the previous session, I shortly presented about the Co2 Innovation Hub, and Embraco is one of the contributors, and we have just recently received your plug and cool unit. So thank you again, because I know you have personally been driving this internally. So the unit has reached us safely, and we look forward to deploying it in a small cold room setup. Maybe I would like to just ask for your comments about the market in Philippines. Is Embraco ready to be again able to provide your R290 solution, hydrocarbon solutions, to the local industry? Are you having some discussions with some of the local companies, or this is the beginning?
Yeah, for the R290 inside Philippines. In fact, before the coronavirus, there's one time I visit, I mean 2019, yeah, when I visit a big OEM customer inside Philippines, we already start talking about R290 application. But for sure, this coronavirus impact a little, but I'm clearly understood the Philippine customers, especially a lot of OEMs, they already start the R290 actions. Especially when we talk about some big company to make some pull up, yeah, for the whole cold chain. Yeah. So anyway, nowadays we don't sell too many compressor. I mean R290 compressor to Philippines, but we already start some business with local OEMs. So I believe, the time changed very fast, yeah, and I believe the Philippine market will grow up, especially when we talk about R290 inside this year or next year. The volume can grow very fast.
Excellent, and you're ready to serve the market. That's good to hear as well. My final question to you is, we have heard also the presentation from Marek Ziglinski, your colleague, who is the chair of the IEC subcommittee. And this was an update on the safety standards in refrigeration. And of course, this is linked to the increased charge of hydrocarbons in refrigeration to, to close to 500 grams for the plug-in systems. Can you please comment on Embraco in terms of, have you developed new line of compressors that can go, basically higher capacities compressors that are your response to this update on the safety standard?
Yes, when we talk about a bigger cooling capacity, that's the target of, that's one of the target inside the NIDAC Embraco. For example, inside this year, we published a new NJX compressor, and this compressor is around a 2.5 horsepower compressor. It's also can be used for R290. And also in parallel, we are developing some new variable speed compressor portfolio with R290. So anyway, Embraco, we never stop the steps to enlarge our cooling capacity, especially when we talk about the hydrocarbon R290 compressor. So anyway, if you have, or if any customer has interest in, is very welcome to log in Embraco website to follow up our new trend for the new product. We will publish the news inside our website, and we believe we can give you better solution in the future.
Excellent. Thank you very much. It was great to have you today joining. Thanks again for contributing to the Co2 Innovation Hub project as well. And I look forward to having in-person interactions, hopefully in the coming weeks.
Yeah. Thank you very much, Jan, and thank you very much for your help, especially when help Embraco to promote R290 solutions. Yeah.
Bye-bye.
Hope to see you soon. Bye-bye.
Bye. All right, so we are now ready to proceed to our next speaker, Maurice from TECO. And we will hear more about the CO2 advancements when it comes to applications in Asia. So the latest from the technology leader in CO2, TECO, and we'll see how these technologies can be applied in Asia. Maurice, if you can hear us, please join us with your camera. We'll test.
Good morning, Jan. Can you hear me?
Good morning. Good to see you again. Hopefully soon.
Yeah. Sorry, when I first started the video, it says that the has been stopped. The host has stopped it.
We will fix it in a moment. No worries.
Okay.
You can go ahead and share your screen with your presentation if you're ready.
Okay.
That should be okay. Excellent. So we got the visual on your. This is your desktop.
Here we go.
Okay, fantastic. All right. Well, thank you. Joining. Thank you.
Okay, let me have a look here. There we go. Looks like the camera's starting now. There we go.
There you go. All good. So the typical studio at TECO. I know that this has been a popular place last 2 years. Your virtual studio. It's great.
Great.
Capacity. All right.
Yeah.
Fantastic. So please, you can go ahead and start, and look forward to the Q&A after.
Good. Thank you.
Thank you. Bye.
So, morning, everybody, or good afternoon for everybody in the APAC region. So just to introduce myself, my name is Maurice Robinson. I work for TECO here in Germany. I've been with TECO since last year now, and recently moved from South Africa into Europe, into Germany. So I'm quite happy to be here with a market leader for refrigeration on CO2 transcritical systems. So today I thought I'd just talk about a few things. Let's get this going here. So what I want to basically talk about is, as we move from industrial refrigeration from retail, because retail has been with CO2 for many years now, but we're moving into an industrial sector. Why choose CO2 for industrial, and also when to use the different technologies, because we have a few good technologies in our hands at the moment that we can use for industrial refrigeration. So CO2 has become the preferred choice for most refrigeration systems around the world at the moment, especially for the low kilowatts, moving all the way up into industrial refrigeration now, large kilowatts. So since the adoption of the CO2, companies have also invested a lot of money into technology, making CO2 more efficient and also making them cost effective. In the beginning, CO2 was a very expensive choice, but as time has gone on and companies have started having large quantities being ordered and produced, obviously the costs come down. So fine-tuning the designs for lower capital costs, and then also increasing the capacities for large kilowatt systems. So gas ejectors, liquid ejectors, flooded evaporators, and smart control systems is very popular now with CO2 these days. And a lot of companies are putting a lot of effort into making these systems happen. Also here at Teco, obviously. So having a look at our opportunities that we've had over the past few years. In 2017, we had a handful of requests for refrigeration CO2 systems that were more than 300-400 kilowatts. And since 2017, our requests for just Teco with more than 550 kilowatts of refrigeration has gone all the way up into the 50s and 60s of requests per annum. And growing. And just remember that some of those requests, even though it's 550 kilowatts that I've got in the information, it could have been a megawatt or 1.5 megawatts. So each offer could have had multiple 550 or megawatt machines in there. So it's grown rapidly, and I think CO2 in the smaller side of the industrial refrigeration is going to grow exponentially over the next few years. So having a look at CO2, when you decide that you want to install CO2, there's a few things that you have a look at. A lot of the times it's costs, because the costs have come down. It's also the requirements, so the corporate and social responsibility that you have with companies, and also contractors and their clients. Their clients also request them to start using natural refrigerants. And then also energy saving is obviously one of the bigger things with CO2. We know that in the past years, there used to be something that some people will remember, the CO2 equator, which isn't there anymore. So having costs, natural refrigeration and energy saving, or all of the above, is a choice of using CO2 at the moment. And a lot of people are using that and making sure that they install natural refrigerants because of the disaster that we're having in the world at the moment with, high temperatures, heat waves, and natural disasters. So one of the things that I want to talk about today is where you have the CO2 system and the ambient conditions, and then also the ambient temperatures per year and when to use what type of technology. So if you have a look at the first graph over here, that's the minimum maximum temperatures for Frankfurt, Germany. So you'll have a look there. You'll see May, June, July, August, and September is the warmest months in Frankfurt, Germany. I'm quite surprised. It's my first summer in Germany, and it's actually quite warm at the moment. So having a look at the maximum temperature, your first instinct would say, well, it's going up towards the 30-degree mark, so we definitely need to put in something into our CO2 system to help with the energy efficiency of the system. But what people don't understand is if you have a look at the bottom graph, for only 250 hours out of the year, Frankfurt in that zone of the high 20s, 30 degrees, and that's out of 8,760 hours per year. So installing something that's going to give you high energy efficiency at a higher ambient might not have a return on investment for you for the longer term. So you've got to take this into consideration. And this is probably one of the better graphs that you need to have a look at when choosing what refrigeration or what technology you want to put into your CO2 system. So this is just an average return on investment that we created with regard to the technologies available for CO2 at the moment in warm climates. Parallel compression is generally a given at the moment, unless it's a cold ambient, then you wouldn't use it. Our own Everlift, which is a Teco patent, which I'll get into a little more detail later on in the presentation. And then Everlift and TecoJet, which is our gas ejector, and then gas ejectors and liquid ejectors. So in the graph, you can see that on the bottom end of the scale, that's where the initial investment would have been, the extra amount that you would pay into your CO2 system. And then going throughout the years, up to 15 years, because we're talking about industrial applications, when the payback's going to be and how much payback you're going to get and energy saving in the future. So you can see that the yellow line with the Everlift and TecoJet wins all of it. And you can see the different graphs as we go along, but I'll get into more detail with that now. So looking at parallel compression, this is what we were talking about. So basically parallel compression compresses a flash gas on a higher suction temperature than what the medium temperature is running at, which gives you that extra energy saving. So generally you would work with parallel compression for any ambient conditions that are above 20 degrees for most part of the year. There is places in, for instance, Southern Africa, where the ambient temperature is very low for quite a lot of the year. So you don't even need parallel compression there because it's not going to give you any payback. And the money that you put into the system wouldn't actually pay itself off. You'll have a 5-10 year payback period. So it's not really worth it. So you always design parallel compression for the maximum amount of working hours and not the flash gas amount. And the return on investment, depending on the ambient conditions, is about 2 years generally. And obviously, like I said before, all of these are estimated figures as well. So looking at gas ejectors, including with parallel compression. So what a gas ejector does is it lifts the empty suction gas to the parallel compression level and then compresses that by the parallel compressor. So what you're doing is you're basically increasing the operating hours of the parallel compressor and the capacity, which in turn gives you the energy saving increase of that. The thing is with gas ejectors, you need a very high ambient condition, or I would say more than 30 degrees, because the motive fluid, which will increase the pressure on your suction fluid, is what you need. So if that's very low, you're not going to get the efficiency out of the ejector. Then parallel compression will probably just take over and then we'll do most of the work anyway. So you would generally design on average the high pressure valve load to be the most efficient at the maximum amount of time. And the return on investment for a gas ejector is probably around about 4 to 4.5 years, depending on the ambient conditions. So if you had to look at this in Germany, that's what it would be, around about, 4.5, 5 years. But like I said, anything above 30 degrees, then you would drop that return on investment. We also have liquid ejectors for CO2 systems. So basically liquid ejectors are the same as a gas ejector, except it's actually lifting the liquid from the system. So the extra parts of the liquid ejector system, you would have a receiver where the suction line would then accumulate the liquid that comes back from the medium temperature evaporators. The low temperature evaporators just work as normal. But the nice part about a liquid ejector is that it lets you run the evaporators at a semi-flooded or a flooded system superheat. So instead of having a 6K superheat or 8K superheat, you would have it on 0 or 0.5. And with your empty evaporator being flooded, you can actually start increasing your medium temperature suction temperature. And just remember that every time that you increase your suction temperature by 1K, so if you're running at, let's say, -6 and you take it to -5, that 1 degree that you're increasing on your empty suction, you're saving around about 4% of your energy while that system's running. So for warmer climates, it's great, but also for lower climates as well. So anything above 25 degrees estimated, liquid ejectors is a very good solution for a CO2 system for energy saving. The return on investment is around about 3 years. With liquid ejectors, you have a lot more technology that you need to put in. For instance, the suction accumulator, you need a liquid level sensor on the accumulator. So there's a lot more hardware that needs to be put into liquid ejectors, which obviously increases the capital costs. But with it running with low ambience, the return on investment also is brought down. So it's obviously also a good solution. Having a look at the Everlift, which is a TECO patent. So what we have done is we've created a system that has a stable superheat at the rack. So what that does is the suction superheat on the MT and the LT is controlled at the actual rack itself and not anywhere else. We also take advantage of having flooded evaporators. And it's a very intelligent control system that always tries to achieve the highest suction temperature at the rack while keeping the superheat of the rack correct, but also having the lowest possible superheat at the evaporators. So this can also be used in conjunction with our gas ejector, which is called the TECO jet. And the nice part about the Everlift from Teco is it can work in all climatic zones. So it can work in the system where it's running in subcritical. It can run in a system that's running in transcritical. It can run in winter. It can run in summer. It can run day. It can run night. So it doesn't matter when the system or the ambient conditions, where they are, the system will save energy all the time. So this added efficiency is also increased on the LT suction line as well, where the other types of technologies can only run or save or flood the evaporators on the medium temperature side. So with regards to the actual technology and the system itself, there's no special considerations for the oil system at all. So it's a standard oil system, and the return on investment, because it's a lot more cost-effective solution on your CapEx, your return on investment only between 1.5 and 2 years. And that's because you're saving money on your low temperature and your medium temperature, and it doesn't matter what the ambient conditions are. If the ambient conditions are high, you'll be saving energy, and if the ambient conditions are lower, you'll still be saving the same amount of energy. So just to give you a quick snapshot of what I'm talking about, generally a refrigeration system these days will run the suction temperature on a medium temperature between, let's say, -9 and -6. And obviously running a rack at -9, you need a lot of capacity out of the compressors, which is going to take a lot more energy. So like I said, the rule of thumb is every degree that you go up, you're saving about 4% on energy. So if you think about it, we can run a Everlift system up to -4 all the way up to -1. So if you take each step there, going from -9, 8, 7, 6, 5 all the way up, you're adding 4% of energy saving as you go along on each step, which gives you a very good return on investment and also very good energy saving. So just to give you a little snapshot of the 3 different types of equipment that I was talking about today. With regards to the oil system, there's some special requirements for gas ejectors with parallel compression, also liquid ejectors, but with the Everlift, it's a standard simple solution. The 3 systems work on medium temperature, like I've shown you, but only the Everlift will actually work on low temperature as well. So we have flooded evaporators on medium temperature and also flooded evaporators on low temperature. Parallel compression is necessary for the gas and the liquid ejector. With Everlift, you can actually use it without parallel compression as well. So you could put it into a colder climate where parallel compression is not needed. High ambience, all of the systems work at high ambience, like I've said. The gas ejector doesn't work on low ambience because in the initial slide, we need that high motive to get the lower pressure gas lifted. Liquid ejectors will run on a lower ambience, but Everlift will run no problem at all, day, night, winter, summer. There's also a little bit of extra experience and know-how that you need for gas ejectors and liquid ejectors. So some special training or some training on the control system, where with Everlift, it's actually quite a simple and straightforward solution, and the controls does most of the work for you. Because it's a very intelligent control system that was developed by Teco, it's basically a few parameters that you add into the controls, and then your system will carry on running on its own. The capex on the gas ejector is a medium capex, so the return on investment at high temperatures could be low, but with the capex on liquid ejectors is a lot higher. The Everlift system comes in at probably the lowest capex costs out of the 3 technologies, and that's why you have high savings winter and summer, and also you have a faster payback on your investment as well. So just having a look at the Everlift system, it's a simple setup and control. It's the lowest additional cost, high energy saving, winter, summer, fast return on investment, any ambient with increases in saving if the Teco jet is added, so even in high ambience or extremely high ambience, and it can be retrofitted to existing CO2 evaporators in any application, so there's no need to change cabinets or any of the other equipment. And it's standard evaporators that are used in the system as well. So it's a very simple, straightforward system that can be used in any application in the industrial section. So that's the power of Everlift. So I welcome any questions. If there's anything, you can go ahead, Jan. Thank you.
Thank you very much, Maurice, as well. Great presentation. This is a very good overview of your different technology advancements and different configurations. You have experience with all the different setups, right? When it comes to CO2 transcritical and different sizes. So my question to you is more about your capacity, your experience in Asia. You know, like, is TECO ready to work on CO2 projects in Asia? What is your, you know, what are your local teams and offices that can be involved in these projects, or any specific plans in that direction, please?
Yes, definitely. So I think if anybody was in the APMA world, they would have known that TECO has opened up a branch in Thailand. We've at the moment we have one of the employees from Thailand that's been working with us and going through all of our systems here at TECO, from manufacturing, planning, quoting, offers, sizing. He's been working with us for over a year already. So we're training him, and he will be going back to Thailand to be the link between ourselves and our Thai branch. We're moving into that area quite aggressively at the moment. We see that with the technology that we have at the moment, we can install CO2 in any ambient condition. And I think that you know, the world is moving and it's catching up. You know, if you have a look at Japan, how they've moved onto natural refrigerants, it's amazing. They were one of the first adoptions of CO2 in that area. So I think with our technology and our support from our head office in Germany with our Thai company, I think we definitely going to start moving into that market a lot more aggressively.
That's great to hear. What is the, you have installed your CO2 technology in so many different markets. What is the best way to start? Is it small and simple, or you can go all the way to large and let's say the latest, you know, on the CO2 configuration? Anyway,
I think, yeah, you know, the world is a very small place at the moment. So it doesn't matter where you're on the world, you can have the support and you can have the technology. And you know, thank goodness that most of the areas in the world have opened up since COVID. So you know, travel isn't a problem anymore. And you know, we have teams that travel around the globe, basically. You know, installing and setting up systems for CO2, whether it's a small system or a large system. And with refrigeration, you know, if your rack's got medium temperature and low temperature, and it's 150 kilowatts or 500 kilowatts, just extra compressors that are built onto it. So you know, I wouldn't say start small and go big. I would just say, you know, do what you need to do and go natural.
Excellent. Yesterday, you know, we had one-day event here in Tokyo, and it was great to meet the industry in person again. And we had a lot of discussions that went beyond the standard refrigeration system. It was more about how can CO2 be used as a brine chiller, and there's application in factory air conditioning using, you know, CO2 system, etc. What are the application, or maybe you can share how many of these systems were installed in these kind of not necessarily niche applications, but not the traditional refrigerated warehouse, right? Kind of air conditioning, brine chilling.
Yeah, so at the moment we've got a whole team of people that are working, you know, every day on specialized equipment with CO2. So we are quoting CO2 systems that has integrated AC, it has a heat pump integrated into it. It's not just the normal medium temperature and low temperature system anymore. There's so many more adaptations and add-ons that we're doing at the moment. You know, we could almost adapt CO2 to almost any type of request that the client has. I don't think it's an issue moving forward with CO2 as a technology for any type of system. You know, we're doing chillers at the moment for water for air conditioning, and that's only for air conditioning. The nice part about CO2 is that you can have different suction level groups on one rack. So we can have low temperature for let's say a freezer room. You can have medium temperature for a big pull down area, You can also have the air conditioning built onto that that's providing cold water at 6 degrees or whatever it is, and at the same time pre-producing hot water. So you know the technology is there, and all you need to do is just have the request and just have the drive to do it. And you know, at TechCo, you know, we don't, although part of our business, our main business is standard refrigeration solutions, we do a lot of specialized equipment as well. So I don't think that's a blockage at all for us as a company, especially.
Thank you. Within Asia Pacific, what markets are you looking into with a priority? Are you looking for new business opportunities, new partnerships to be formed?
For sure, definitely. So, like I said, we have a branch in Thailand, which will eventually start manufacturing the CO2 systems on their own. And you know, TechCo has a range of solutions from a small little standalone system all the way up to, like I said, specialized systems. So we've got the full range. So the markets in the APAC region, our product fits in with whatever the clients actually need. So I don't see an issue with any of the markets.
Right. And my final question is, just in previous session, I presented shortly the update from the food cold chain project in Philippines, and TechCo has joined on board as one of the contributors with your expertise, your know-how on CO2. So I don't know where you're based, in head office in Germany or somewhere in Asia, but it would be great to have you or your colleague to be joining us sometimes in September when we do the grand opening to help the industry to understand the CO2 better and share your expertise. I'm
sure we'll be there.
Excellent. We'll be in touch regarding.
Definitely.
Thank you again, Maurice, very much.
Thank you for your time.
Always a pleasure.
It's a pleasure. Thank you very much.
Thank you. Take care. Bye.
Bye-bye.
All right. And with that, we are now ready to proceed with our final presenter in this session. Gabriele, welcome. Welcome.
Hello. I think that you can hear me.
Yes, we can hear you, and welcome to the day 2 of the Atmosphere Asia Pacific Summit. We have had a chance to meet yesterday, so today we will hear more about your projects with CO2. So very much looking forward to that. And please, whenever you're ready, you can share your screen, and we can start the presentation. Maurice, if you can please stop sharing your screen. I believe that's still, or we can perhaps.
Right.
I will be able to. I'll be able to do a little bit of a trick here. Okay, so Gabriele, you can please go ahead and share your screen.
Yeah, I think that you can see my screen, right?
Yes, we can. And if you can just enter the full screen, and then we are ready to go. Great. Thank you very much. All right.
Okay, good morning and good afternoon to everybody. My name is Gabriele Cernani. I'm the Overseas Sales Manager for Arne Korea, and I'm personally in charge for overseas sales in Northeast Asia for Arne Group. Today, I'm going to talking about the use of CO2 transcritical system in South Korea, and I'm going to do it by explaining 2 case studies that we had in Korea. The first would be the use of this system in small retail stores. And the second one would be the one about the use of transcritical CO2 system in a hydrogen charging station. So let me start with a brief introduction about what is ARNEG. Yeah, of course, the majority of you will know what ARNEG is. ARNEG is an Italian global company because we have been established in Italy 69 years ago, and but we are present with the factories and the representative offices all around the world in all the continents, and we have also representative offices in Manila and a factory in South Korea where I'm working, and. As you can see from the bottom part of the slide, we produce a lot of products that can match with the cold chain sector. Refrigerated cabinets, plug-in remote type, refrigeration systems that, of course, we consider also CO2, cold storage and isothermal doors, and checkout shelves and all the necessary for retail sector and cold chain sector. In the next slide, I would like to briefly introduce two lines of our products. On the right side, you can see some of our plug-in cabinet solutions that are available also with R290. And as you can see from the screen, these products are a real good combination of innovation, performance, sustainability, but also high standard of design. On the other side of the page, you see some of our CO2 refrigeration system solution. And in the chart below, you can see the range of our available products. As you can see, our product can match with a quite huge range of needs of your clients, from really small store to big storage. Here you have a map with all the installation that we had with our CO2 refrigeration systems. As you can see, the majority of our installation are located in Europe and Italy, of course, because, you know, European regulation about the use of freon gas and energy friendly and environment friendly has started before, but we did our installation with these systems also in North and South America, Africa, Oceania, and now we are starting also in Asia to push with sector. But let's move on directly to the two case studies of this presentation. Yeah, of course, I don't need to say why we have to use CO2 as a refrigerant, because it's natural, it's not flammable and not toxic. It has a ODP that is equal to 0 and GWP that is really low, equal to 1. It has low cost and it's available everywhere, etc., etc. Okay, the first case studies is the use of these CO2 transitional systems in small retail stores. Everything started when in 2020, Korean government say that they want to go green and want to reduce the CO2 emissions, etc., etc. So one of our main customer in Korea asked for an eco-friendly store. And for the stores, I mean, mini retail store. And he asked for energy-saving features, eco-friendly gas, and the reduction of CO2 emissions in general. So we installed this store in Seoul in 2021, and from then we started the testing situation. And there are only 2 stores with these features in South Korea. In order to match with the client request, we used transcritical CO2 condensing units for 2 horsepower and 4 horsepower. We use high efficiency DC compressor and DC fans in order to improve the efficiency of the CDUs and the cabinets. And we also use the free flow price holder in order to maintain the temperature inside the cabinet, especially because most of these convenience stores use open multi-decks without doors. And after using these benefits, we consider our data and we saw quite good saving in the electricity bill, because we saw a reduction in energy consumption that is equal to -17 if you compare the same situation, the same store, but using not the features that I explained before and the use of R410 or similar gases. We use CDUs that are designed as plug-and-play solutions, so it's are really easy and flexible to use and install. We have CDUs that are available with capacity with 2 horsepower and 4 horsepower for medium and low temperature, so are really flexible and can use also for this kind of stores that in this case was around 90 square meter. And we design our CDUs with a prototype case and CD fans in order to grant quite energy saving operation. Then we had to consider also the other requests that our client asked for, so the reduction of CO2 emissions. And yeah, of course, we have to consider the energy saving that we considered before. That was minus 17% in general. And it was the result of energy saving that is equal to minus 25.4% for the low temperature cases and minus 16.2 for the mid temperature. And we evaluate the CO2 energy CO2 emissions reduction. It's equal to minus 67%. This is because of direct influence and indirect influence. The direct influence is the fact that we use CO2 instead of R404, and a direct influence of the CO2 emission reduction that is linked to the reduction of the energy for running this store. So at the end of this first case, we can say that this store use environment-friendly solution because we use CO2 as a refrigerant. It's eco-friendly. We saw energy efficiency, especially because our BLDC is combining 2-stage compressor with a split cycle to increase the performance and the efficiency of the whole system. And so we had quite a good reduction in energy consumption. And the fact that we have used a low GWP refrigerant gas with a reduction of energy consumption, we can help to reduce the CO2 emissions for this kind of stores. But let me go on for talking about the second case studies of this presentation. So the use of CO2 sealer for hydrogen charging station. As you know, nowadays many institutions and companies are investing in H2, hydrogen, as a possible alternative for the use of fossil fuel, for using for cars, buses, trucks, and other kind of transportation. And here you can see on the left side of the slide the process of producing, storage, and distribution of CO2. And as you can see here, you have a dispenser, and in the dispenser you need a chiller. Because here the hydrogen must change its status and temperature from a positive temperature to minus 40 degrees Celsius. So you need a chiller. And usually, for all the installation that have been made in Korea, they use a system with R404, but we want to use CO2 systems because we want to create this green combination of the reduction of the emissions of CO2 granted by the use of H2 as a fuel, plus the use of CO2 as a refrigerant gas for the distribution. So we want to create the greener solution as possible. This is a project that Arneg is doing, thanks to it was promoted by Korean government in combination with Arab Emirates government. Practically, we are in the middle of 2-year testing. The testing started this year in 2022 and will go on until the end of next year. And from 2024, there will be the first installation for multiple installation of multiple charging station of hydrogen in South Korea with this system. And from 2025, there will be the multiple installation of this kind of system in Arab Emirates. Then, in this slide, you can see what kind of system we select and how the system is working. As you can see here, you have a compressor for a medium temperature and low temperature, and you use an AC inverter. For doing this, we decide to use a global model that is Transitional Systems that is made by Arneg Italy, and the use of a condenser that is outside. Usually in the past, when they use the traditional system with R404, they had 2 different compressors, one for the medium temperature and one for the lower temperature, and 2 different condenser. But thanks to our engineering and our system, we can use only one combined compressor rack. On the right side of the page, you can see some test condition and equipment that we use. As you see, we use minimum temperature equipment that is equal to 15 kilowatts, and we install 4 kilowatts for the low temperature. You have to consider that these are the power that we are using for the test. When we will install the real charging station, we will use 4 times the power that you can see here. Then you see some other features and characteristics of the system and the test, and you have to consider, keep in mind, plus 41 degrees Celsius, that is the temperature of the environment that we consider. Then another point, in order to maintain performance in the hot summer and maintain the constant cooling capacity with the really hot season and really, how can you say, difficult weather condition, we use this spray water for cooling the gas in the cooler coil. So you have a tube with several holes that is installed around the cooler. And when the temperature is too high, the water comes outside from these holes and reduce the temperature in the air, so you can maintain the constant cooling capacity for this system. So, in conclusion, which are the benefits of using CO2 system in this kind of solution, and what are the challenges that we face, and what's our system improve? So we saw a reduction in refrigeration charge because of the quantity of CO2 needed for this refrigeration. This kind of system is 1/3 less if you compare with the same system, but the previous one that use R404. We have an improvement in the piping fittings that reduce the leakage of the refrigerant, so it is equal to minus 75%. In terms of performance, with similar climatic condition, we saw similar performance if you consider CO2 systems and system that use 404A. In terms of the improvement of energy efficiency, we saw an improvement with CO2 solutions that is equal to an improvement of 15%. So an additional limitation of CO2 emissions. So we had this green combination of use H2 as a fuel and the use of CO2 as a refrigerant gas in its distribution. Thank you.
Thank you very much, Gabriele, for your presentation. Very interesting application with the hydrogen charging stations. That's something that we have not yet reported before. And you have mentioned that a number of these pilots will be installed in the market in Korea in 2024.
Yeah, right. Yeah, we have 2 years of testing. This year is the first year. Next year will be the test, and multiple charging station will be installed in 24. Yeah.
Okay, and for this application, it was the larger system, the rack system, rather than the condensing units that you deployed in the retail store.
Yeah.
Okay.
Right. For this case, we use this system that is made by Arneg Italy. Yeah.
Very interesting. Would it be
we prefer to import directly?
Okay, and these small racks, would they be the first installations in Korea for CO2 transcritical by Arneg, or are you working on some other new applications? Because this is again something different, right? We usually talk about retail, and now we have the future fuel for transport infrastructure. So that's right. Application.
Yeah, we installed several of these.
Are you working on some other applications? Is there something you can share in terms of what will be the direction for the Arneg in Korea when it comes to CO2 transcritical? Are you looking into even larger systems?
We are considering also the use of this kind of system for semiconductors, for companies who create semiconductors. As you know, Korea is quite famous for this kind of products, and also kind of other kind of installation or kind of products or kind of industrial application for CO2 systems. Yeah.
Okay. And do you get engaged with the policymakers in Korea? Do you see there is an opportunity for some kind of a subsidy for this infrastructure buildup?
Yeah, sure. Because Korea in 2020 made this, can I say, announcement that they want to reduce as much as possible the CO2 emissions, etc. So they want to push CO2 as a possible replacement of old, we can say, refrigerant gases.
Mm-hmm.
Yeah,
it would be rather sad to see, the future fuel solution, hydrogen, right? That many refer to be then cooled by 404 or something as old as and nasty as that. So that's a great initiative to complement this sustainable solution.
Yeah.
Right. Well, let's see if there's any questions from the audience. Okay, I have one question. I believe that's to your session. I will read this out. Looking at the systems being put into the Middle East, how much do you expect the higher ambient temperatures to affect efficiency of the CO2 cooling? As far as I know, ambient temperatures in the summers in UAE consistently sit in the mid-high 40s.
Yeah, I know you and the situation. In order to prevent, in order to match with this high temperature that sometimes is plus 40 degrees, we use a parallel system for in case we use this system in the Emirates.
All right.
Yeah.
And that deployment, that test will be running in 2025, you mentioned?
Yeah, right.
Okay. Do you hear about this application being, tested or tried in Europe?
No.
Okay.
No. Not yet.
There's a couple hydrogen charging stations in Japan. I'm wondering what kind of cooling they are deploying. Since you mentioned that each of these stations, there have to be cooling provided to the, was it dispenser that you referred to? Oh, dispenser, yes.
Yeah, it's the dispenser. Yeah, at the dispenser, you need to have this chiller in order to change the status of the H2, because here you have, this is the point where I think you can see my screen, right?
Yes, we can.
Yeah, this is the point where the refrigeration circuit is linked with the H2 dispenser. Is where the H2 changes status and temperature before entering inside the cars or inside the trucks, because it passes from a positive temperature minus 40 degrees.
All right, very exciting application, and we look forward to hearing more about when this is deployed in the market, and to learn more about how the system performs. So please let us know when you have anything more to share about this application.
Yeah, sure.
All right. Well, thank you very much again for joining today as well. I think we can conclude this session. So thank you, Gabriele, and thank you. I see you, Mr. D, as well. Back there. Good to see you both again, and thank you to all the panelists of today's session on the state of the industry in Asia Pacific. So we have learned a lot about new applications, new technologies being increasingly available for this part of the world, and we look forward to seeing more and more new projects and new solutions based on natural refrigerants in Asia Pacific. Keep us informed if you have any exciting project to share, to talk about.